topic for today, graphing square roots. So what does a square root look like on a graph? Now, you guys have the skills that you need to graph anything. The way that you do that is you take an equation. So let's say I have y equals the square root of x. Then you make a t-chart. You plug in values for x and find the corresponding y. Now you want to try to find easy values so that they're not really hard to plot on the graph. Let's say if x is 0, that's going to be a pretty simple y. Y would be the square root of 0 is 0. Another one that's fairly simple. If x is 1, what's the square root of 1? 1. So far we have a really kind of silly graph. It almost just looks like a line going up. But that's not going to be enough points to graph this. Right? If we were graphing a line and we knew it were a line, 2 points is enough to make a line. We want to keep going in this case. 2 is not a very easy thing to plug in for x. We would get the square root of 2 for y, which is like 1.414. Not the easiest thing to graph on it. So instead, let's plug in the next perfect square, 4. The square root of 4, so plugging it in here, is 2. So x is going to go all the way out to 4, y is going to go up to 2. And then let's do another one. Next perfect square is going to be 9. So 4, 5, 6, 7, 8, 9, and y goes up to 3. And now you can start to see the shape. It's kind of this sideways arch. Okay. Not the best drawing ever. But there's my graph of the square root. And there's things on here that are really important to notice. Mostly they fall into the category of the domain and the range. So do you guys remember what domain and range mean? The domain of a graph or of a function is all the possible x values. And the range is all possible y values. We're used to graphing lines where the domain and the range are all of the real numbers. A line extends forever in any direction. But with a square root, that's not true. So let's think about the domain. And the way I remember these, domain and range in alphabetical order, dr, right? And x and y in alphabetical order. So domain goes with the x, range goes with the y, just like alphabetical order, d comes before r and x comes before y. So it's just a little helpful trick to remember them. But the domain for this function, all the x values, ends right here. I can't plug in -1. I can't even plug in negative 0.000001 because the square root of a negative number is not a real value, right? It's not a real number value. So my domain, and I'm going to just write it like this, capital D, I'm going to write it as x is greater than or equal to 0. So x has to be 0 or greater in this function. And then the same thing happens with y. The range, y, again, we're never going to get a negative number as the square root of x. At least not with the way that we've defined square roots. So y must be greater than or equal to 0 as well. And that's my range. So that's the basic function. y equals the square root of x. It's this curve that comes up. It hits all these perfect squares as it goes up, right? So 1, 1, 4, 2, 9, 3. Yeah?
If you were to put in 2, let's say for the x,
Mm-hmm.
it would give you a really weird y.
Mm-hmm.
You could still graph it.
Yeah. This would be 1.414.
And then you could do 1.5 or something, right?
Yeah, you could graph anything. So 2, right, would be 1.414. It's like right here on our graph.
You could make
That
it like
point.
really.
So there are infinite points along here. I could plug in 0.39725 as my x value, and I would get something for y. But
Yeah.
it wouldn't be very easy to graph. So that's why I picked these. It's not because 2 is not on my graph. It is. It's right here. It's just that I don't want to choose that point because it's harder to find 1.414 than it is just to find 2. But that's a good point. So this is still included in your domain. All right. Yeah.
Couldn't the y's be a negative number because the square root of 4 would be 2 or negative 2?
Right, so we're going to ignore that. For this graph, when you're graphing square roots, your y's, your answers are going to be just a positive value. Partly that's because remember how we talked about the vertical line test? So if I had graphed the negative values, it would kind of mirror itself here. And it's no longer a function because it doesn't pass that vertical line test. This line would hit the graph into it. So the function y equals the square root of x is just this half curve sort of thing. Okay, what happens if we start to move this around? There's a bunch of ways that we can move it around. So instead of y equals the square root of x, what if we had y equals the square root of x, and then out of the parentheses, minus 1? So again, let's just make a t-chart. X, y. In this case, the same things for my x's are going to give me simple answers for my y's. Because what I want to look at is what is underneath this square root. What is underneath the square root is still x. So I'm still going to pick perfect squares for my x's. I'm going to pick 0, 1, 4, 9. I think that'll be enough. And then I'll still get integer values for y. Except I'm not going to get the same integers. So when I plug 0 in here, y equals 0 square root minus 1, which is 0 minus 1, which is negative 1. When I plug 1 in here, I'm going to get 1 minus 1, so now I have 0. When I plug 4 in here, I'm going to get 2 minus 1, now I have 1. When I plug 9 in here, I'm going to get 3 minus 1, which is 2. And if you notice, this is just the same sort of curve moved down 1 point. So instead of starting here, I'm starting right here, 0, negative 1. And then I'm going to 1, 0. And then I'm going to 1, 2, 3, 4, 1. And then I'm going to 4, 5, 6, 7, 8, 9, 2. So it's the same curve that I had before. But it's just moved down a little bit on my axis. It's still the same shape though. So take a guess. What do you think it would look like if I did y equals the square root of x minus 2? What would that graph look like? Yeah, I would just do the same thing, but one more down. So I would start here, and then go here, and then here, and then here. And that would be my graph of y equals the square root of x minus 2. So this number here is just moving the graph down. Now what if I had y equals the square root of x plus 5?
It's like
You're just
y
adding
intercept.
Yeah, I would start up here. 1, 2, 3, 4, 5. I would start right here, and I would have that same curve shape.
Yeah.
Yeah, it is. It is just like slope-intercept form in that sense, right? This is changing where I am up and down. Okay, it's going to get a little bit more complicated than that. So, because there's so many ways I can change it. So what if I had, instead of y equals the square root of x minus 1, y equals the square root of x minus 1. Now the 1 is in the square root. So what do you notice about my t-chart immediately? If I want to get integer values for y, I have to change my x's now. Right? If I plug in 4, y is going to now be the square root of 3. So instead, I'm going to have my x values that I choose for my t-chart be 1 bigger than those square roots. So I'm going to start with 1. Right? Because if I started with 0, y equals the square root of 0 minus 1, y equals the square root of negative 1, that isn't possible. I can't really start with 0. Which means that my domain has changed. So instead I'm going to start with 1. When x is 1, y is the square root of 1 minus 1, which is 0. Then I'm going to do 2, because the square root of 2 minus 1 is 1. Now I'm not going to choose 4, I'm going to choose 5. So the square root of 5 minus 1 is the square root of 4, which is 2. And then what do you think is the last one I'm going to choose? Not 9, but 10. And so effectively, I've moved my graph over. Right? So instead of starting here, now I'm starting here. 1, 0. And then I'm going over to 2, 1. And then I'm going over to 3, 4, 5, 2. And then 6, 7, 8, 9, 10, 3. So I have that same curve shape, just moved over. But notice, when it was square root of x minus 1, that moved it down. When the minus 1 is inside the square root, it actually moved it to the right. Okay? So it kind of had the opposite effect. So if we look at this, y equals the square root of x minus a number, or plus a number, and then plus or minus another number. This number moved it up or down. This number now that's in the square root, so this minus 1, is moving it left and right.
But if it said plus 1, like
Yeah, so what if it said plus 1? Which way would we move?
To the left.
Exactly. You've already figured it out. Y equals the square root of x plus 1. Now think about it. How am I going to get my 0 for y? X will have to be negative 1. How am I going to get 1 here? X would have to be 0. 0 plus 1 is 1. How am I going to get 2? Well, 3 plus 1 is going to be 4. Square root of 4 is 2. And then how am I going to get 3? 8. 1 less than 9. 8 plus 1 is going to be the square root of 9. So now I've moved it over this way. I'm starting here, and then I'm going like that. Let's see, 1, 1, 2, 3, and then 8. So I've got this same shape, if I could draw it perfectly, just moved over to the left. Alright. There's a couple other things that can happen here. And you can think, just like we thought of adding these numbers as being like the intercept and slope-intercept form, now we're going to sort of look at the slope of this graph. So what if we had y equals 2 times the square root of x? Again, just go back to your teacher. X and y. I just have x alone in the square root again, so I'm going to pick my perfect squares as my x values. 0, 1, 4, 9. But now, if I plug 0 in, I'm still going to get 2 times 0, which is 0. But if I plug 1 in, I have 2 times 1, which is 2. If I plug 4 in, I have y equals 2 times the square root of 4, or 2 times 2, which is 4. And if I plug in 9, I have 2 times the square root of 9, 2 times 3, which is 6. Okay. What happened? All these numbers are doubled. They're twice as big. And so on our graph, I'm going to graph y equals the square root of x first. So that was 0, 0, 1, 1, 4, 2, and 9, 3. This is the square root of x, right? Y equals 2 times the square root of x. 0, 0 is still on this graph. So I still have this point. And I have 1, 2, 4, 4, and 9, 6. Oh. I need like a ruler that does square root curves. It'd be a good invention for math teachers. So it's the same basic shape if I had drawn it well enough, but it's like twice as big. It's like twice as tall because of this 2 out. So it's getting bigger this way. Starts at the same place. So does this value change the domain or the range of the function?
No. Yeah.
What is our domain and range of this function?
Domain is up and down. It's the y.
Domain is the x's, because
Oh.
x is first
Yeah,
alphabetically.
Range.
So what is our domain here? It's everything past, right? X is greater than or equal to 0, which is the same as it was for this. What is our range? Yeah, everything y is greater than or equal to 0. Everything. So the domain and range don't change based on multiplying. Okay? That multiplying affects the height of the graph, kind of like the slope. It's not going to affect side to side. It's not going to affect up and down. And so it's not going to affect the domain. All right, last one. Last example. I'm going to leave this guy on there. So now, what do you think I'm going to do for my last graph? You want to guess? Y equals what? Okay, we could think of dividing as multiplying. So if I had like 1/2, it would just 1/2 of the square root of x, it would make this go smaller, right? But what if I multiply or divide within the square root? Y equals the square root of 2x. This is going to get a little weird. Because there's no longer a really simple way to get integers for x and y, right? So if I want my x to be, if I want my square root argument, what's under the square root, to be 0, x can be 0. So I'm still starting here. But now, how do I make this square root argument turn into 1, the next perfect square? What does x have to be to get the square root of 1?
1/2.
Yeah, x has to be 1/2, right? And there's not really a simple way to avoid now using some fractions. So 1/2 times 2 is going to give me 1. Square root of 1 is 1. So now I have 1/2, and I'm already up to 1. And what if I want the next possible perfect square argument, which is 4? How do I get this to be 4? X would have to be 2. 2 times 2 is 4, and the square root of 4 is 2. So now when I'm at 2, I've got 2. What's going on here? Let's do one more point. So I want this whole thing to be equal to 9. What does x have to be?
4 and
Yeah, 9/2, which is 4.5. So then 2 times 4.5 is 9, square root of 9 is 3. So I have 1, 2, 3, 4 and a half going up to. This made it bigger, just like when I had 2 out front. How come it did that? Why did it do that? So if we think about what this is, we could simplify this to be y equals the square root of 2 times the square root of x. The square root of 2 is just a number. It's not a very friendly number, but it is a number. Y equals 1.414 ... times the square root of x. So we just made our graph bigger this way by 1.414 ... Right? So this is not really any different than this. It's just a little harder to graph. But it's going to have the same effect. It's going to make it bigger or smaller. Right? So if I had y equals 1/2 of the square root of x, which is the same thing as y equals the square root of x over 2, which is also the same thing as y equals the square root of x over 4, like that. All of these are the same. So dividing, fractions, all of these are going to look the same. It's just going to shrink my graph by 1/2. So 0, 0 is going to stay, 1, 1/2, 4, 1, and then 9, 1 1/2. Okay. So this graph would just be the same curve shrunk down a little. So, let's take a look. If I have y equals, I'm going to say a times the square root of x plus b plus c. Actually, I'm going to make this a minus, because I want you to remember that this moves it the opposite way in your minute. And I also want to write this, that this could be either under the square root or not. It doesn't matter. So So the A will make the curve taller or shorter. Right? So think slope. This was y equals the square root of x. This was y equals 2 square roots of x. Just twice as tall. And then this was y equals 1/2 square root. The b, what is the b going to do? B will move the curve left and right. So this is y equals the square root of x. This is going to be y equals the square root of x minus 1. Moved over that way 1. So it's reversed. And this over here, this is y equals the square root of x. So moved over that way. And then C will move the graph up and down. So here's y equals the square root of x. Here's y equals the square root of x minus 1. And here's y equals 0. So we're shrinking and growing our graph. We're moving it left and right, or moving it left and right. Now, we can do multiple things at once. So you can make the graph bigger and move it over to the right and move it down the y-axis, right? So you could have like a really complex equation that would do all of these things. So I want to talk about when you see an equation, just very quickly, what do you do to graph y equals the square root of x type equations? What you want to do is make your argument the perfect square. So you're looking at this like x minus b or ax minus b, whatever is under the square root. So you're going to use this when it's more complicated. Whatever is under the square root, that's called the argument of the square root. And then pick x values that make it a perfect square. So if I'm graphing y equals the square root of 2x minus 1, I have to pick x values that are going to make perfect squares. So I'm thinking, okay, I want this to be 0. 2x minus 1 equals 0. So 2x equals 1, x equals 1/2. That's going to be my first x value. Now I want this to be 1. 2x minus 1 equals 1. Add 1, 2x equals 2. X equals 2 divided by 2. This is my second x value. What's the next perfect square? 0, 1, 4. So I want 2x minus 1 to equal 4. 2x equals 5, x would equal 5 halves. That's going to be my next x value in my t-chart. Then I'm going to come back to my t-chart. I'm going to say, okay, x is 1 half, x is 1, and x is 5 halves. I don't really have to think that much about my y's, because I know now I'm treating this as this whole thing, right? I know that 1 half is going to make this whole thing be 0. So my y is going to be 0. I know that 1 is going to make this whole thing be 1. I know that 5 halves is going to make this whole thing be 4, or the square root of 4. And so the y's will still be there. And I'm not going to give you stuff that's too complicated, because as you can probably see, this can really go on. And in Algebra 2, you will see a whole nother extension of this sort of formula. Let's take this one. All right.